So now let's move on to classification machine learning model evaluation. And the metrics we're going to use or speak about today is the score function, the area under curve and the receiver operating heuristic curve, confusion matrix, and cross-validation score. So now let's move on to the score function. So here I'm going to create a baseline machine learning model like that we did in previous lessons. So let me import the necessary libraries. Let's run that cell. So now let's create our baseline model. I'm going to do this in one cell, and we did this in previous lessons. So I'm going to upload our heart disease and put it in a data frame. Next, I'm going to set the random seed. And I explained what each of these lines of code do in the previous lessons. Then I'm going to create X and Y. So X is our heart disease. And we just want the variables, so we're going to drop the target. Then we're going to split the data into training and test sets. Now let's initialize our random classifier. Let's do our training. Then let's look at the score. And we have an error. It should be read CSV. And you see we got a score of 0.85 or 85%. So this is the first way how we do our model evaluation using the score function, the score function from scikit-learn. And we've done that before, so it shouldn't be new to you. Now let's move on to the area under curve and the receiver operating heuristic curve. So the area under the curve is used to summarize the performance of the model. The higher the AUC, the better the model is at distinguishing between classes, and the raw curve is a comparison of a model's true positive rate versus the model's false positive rate. So the true positive, it means that the models predict 1 when the truth is 1. Or in our example, it predicts a person has heart disease and it is correct. The false positive means that the model predicts 1 when the truth is 0. And in our example, it means the model predicts a person has heart disease and the model is wrong. The true negative means that the model predicts 0 when the truth is 0. And in our example, it means that the model predicts a person does not have heart disease and the model is correct. And the false negative means that the model predicts 0 when the truth is 1. Means that the model predicts a person does not have heart disease and the model is wrong. So let's predict the probabilities for each class on the test data. Let me just write a note. Predict the probabilities for each class on the test data, which is the X test. And let me see if we imported the rock score. Yes, we did. So we don't need to import that anymore. So let's make a variable called yprobs, set that equals to our classifier, predict underscore proba, and then we write the X test. Then let's look at our yprobs. Okay, this is too long. Let me just get the first 10. So we're gonna do that using slicing. Let's run that. And you see we have our predictions. Remember, this one is the zeros, meaning someone does not have heart disease, and this one is the one. So here in the first row, it shows that someone does not have heart disease. So to calculate the AUC and ROC score, we need all the positives. So we need all the ones on this side, which is the 1. So let's create a variable called yprobs positive and set that equals to the yprobs variable that we just created. And let's do some slicing. And the first argument, this means that we're going to select all the rows, and then we're going to put a 1 here, which means we only want the 1 index, so this is 0 and the next one is 1, so we only want these, which is the positives. So we're going to select this second column. So now let's look at the yprobs positive. And we only want 10. Okay, I spelled positive wrong here. And let's run that. And you see we have only this side, the first 10 of all the positive. So now we can calculate the ROC score, or the ROC AUC score. So let's create a variable ROC AUC, and we set that equals to rock up score. And the first argument it takes is the y test, and then the y positive, the probability positives. And now let's look at the score, and we see we got a score of 0.93. And we use the yprobs positive to calculate the rock up, because the score measures how well the model ranks positive class probabilities, which is class 1, and compared it to the negative, which is the 0, across different thresholds. So now I'm going to show you how to display the curve. So let me write a note: display rock curve with sklearn. So we have to import from sklearn.matrix. We want to import the rock curve display. Then I'm going to create a variable called rock display. Set that equals to the rock curve display dot from predictions. So the arguments it takes is our y test and the yprobs positive. And let's give it the name ROC. Supposed to set that equal to ROC curve. And let's run that. And here you see we have our rock curve, and the score, the AUC score is 93, and the area under here is the area under the rock curve, which is 93. Now let's move on to the confusion matrix. And the confusion matrix is a quick way to compare the labels a model predicts. Let me spell that correctly. Model predicts and the actual label is supposed to predict. Let me add some more cells here. So we have to import the confusion matrix from sklearn. And let's set the y underscore predictions to equals clf.predict. Then we put our x test because we want to make predictions from our testing data. And then let's call the confusion matrix function. Arguments it takes is our y test and our y predictions. And let's run that. So let me explain what is happening here. So the first row, it corresponds to the actual negatives. So 24 is the true negatives, which means there were 24 times that the model correctly predicted negative, or correctly predicted that someone did not have heart disease. And the 5 is the false positive, which means that there were 5 times that the model wrongly predicted positive when it was actually negative. And the second row, which is here, corresponds to our actual positive. And here you see there were 4 false negative, meaning that there were 4 times the model wrongly predicted negative when it was actually positive. And this 28, which is the true positive, which means that there were 28 times that the model correctly predicted positive. We can do this another way using sklearn to make it look more visually appealing. So from sklearn matrix, we're gonna import confusion matrix display. So we're gonna call our confusion matrix display, and we have to put the dot from predictions, and that takes our y test and our y predictions. Now let's run that, and you see it display it more appealing. So when it predicted 0, and we go up here and we go to the left, we see this is the true labels. So there were 24 times that the model correctly predicted negative, which means the model 24 times the model correctly predicted that an individual did not have heart disease. So the model predicted 0 when it was actually 1, so it got it wrong 4 times. And here the predicted label is 1, and you see here is 28, and if we go to the left, the true label is 1, so it's 28 times that the model correctly predicted 1. And here there was 5 times that the model predicted 1, but the true was 0, so it got it wrong 5 times. Next, let's move on to the classification report. And if you want to pause and go through all of this to see what it means, you can. But I'm just quickly going to show you how to bring the classification report. So from sklearn.metrics, we're going to import classification report. And then we're going to print classification report, and in the arguments we put the y test and the y predictions. Now let's run that, and you see we got the classification report. So looking at here, we have an okay report, meaning that when it predicted 0, it was right 86% of the time. When it predicted 1, it was right 85% of the time. If our model was perfect, we would see 1 in these. The F1 score is a combination of the precision and the recall. The support is the samples, so we had 29 zeros and 32 ones. The support is the number of samples each metric was calculated on. The macro average is the average precision, recall, and F1 score between classes. So the classification report gives us a range of values for the precision, recall, and F1 score, and we can also find these metrics using sklearn functions. So let me create more cells to show you this. So from sklearn.metrics, we're going to import precision score, recall score, and the F1 score. So now I'm going to print the precision score. Then under here, I'm going to call the function precision score, and it takes our y tests and y predictions. Then I'm going to print the recall score. And then we're going to use our recall score function. Then it takes our y tests and y predictions. Let me correct this here. Then I'm going to print the F1 score. And then that also takes our y tests and y predictions. Let's run that. See, we have an error here. I made the same mistake. Let's run that. And you see we got our precision, recall, and F1 score. So now let's move on to cross-validation score. So we've gone far beyond accuracy with a plethora of extra classification evaluation metrics. But the thing to note here is that all of these metrics has been calculated using a single training and test sets. This is okay, but for a more robust way to calculate a model, we could use the cross-validation. And what the cross-validation does is that it calculates various evaluation metrics using cross-validation, or sklearn's cross-validation score function, along with the scoring parameter. So now let's import the cross-validation score from sklearn. So from sklearn.model_selection, we want to import cross-val score. Then let's set up a random seed. So if you're following along, your data will be split the same way as mine. Set that to 42. Then let's call our cross-val function. And then it takes our random forest classifier, which we stored in the CLF variable. Then it's going to take x, y, and then the scoring we want to use equals accuracy. And this should be in between quotes. And the crossfolds, we're going to set that to 5. So what does this parameter means? That it's going to split the data into 5 different ways, and it's going to give us 5 different scores. So now let's run that. And you see here, it splitted the data one way, and we got an accuracy of 81. It splitted the data another way, we got an accuracy of 90. It splitted the data another way, and we got 83, 78, and 73. If we put a 3 here, it would only split the data into 3 sets. So let's run that. And you see, it split the data into 3 sets. But let's keep it at 5. So now we're going to take the mean of all these values. So let me copy this, bring it here. Then I'm going to create a variable called cross-val accuracy. I'm going to set that to np mean. And in between here, I'm just going to put this that we wrote in the previous cell. Control C to copy, Control V to paste. And now let's look at the mean of our cross-validation score, and we use 5 folds. So cross-val accuracy. And let's run that. And you see we got a mean of 0.82 or 82%. So with this parameter, we use the accuracy. We got a value of 0.82 or 82%. If it's 1, it means that the model is perfect, but no model is perfect. And if you're getting a value of 1, you need to recheck what's happening. So here, when we use the cross-validation score, we split our data into 5 different sets. Then we take the average. We got a score of 0.82. And then when we only use train test split, when we go up here, we got a score of 0.85. So now we can find the cross-validated precision, recall, and F1 score. The only difference from here is we need to change this into precision, recall, or F1 score. So let me just copy this, Control C, Control V. And the only thing we're going to change here is the scoring parameter, and we're going to change it to precision. And let's run that. And you see with the doing our cross validation, we got a precision of 83. And when we only did it using train test split, we got a precision score of 84. So now let me do recall and F1. So Control C, Control V. And the only thing we change here is precision to recall. And let's run that. And you see we got 85 using cross validation. Let me go up here. When we use train test split, our recall score is 87. So cross validation is a more robust way because we're splitting our data into 5 different sets, or whatever amount we want to split it into. We just change the CV parameter to how many sets we want to change our data into. So now let's do lastly let's do the F1 score, Control V. And we change this to F1. Now let's run that. And you see we got our F1 score using cross validation and splitting the data into 5 sets instead of just splitting it into 1 training and test set.